I'm currently doing it. All right, we're here with period 7, our blue class. All right, we are going to be recording how to solve absolute value inequalities. This is one of the most challenging things we're going to do all year. So I'm going to make sure that we're focused. Let's put the soccer marker down. You don't need it, Frank. Let's get focused. You have something to write with. Your notes are out, Anthony. Ready to begin. All right, it's going to take every moment. You got to be focused. Every moment. So let's first look at this absolute value inequality. The absolute value of x is less than 3. What are some numbers that are going to make this true? 2, okay? The absolute value of 2 is 2. Bless you. 2 is less than 3. So 2 is going to work. What's another number? 1. 1 will definitely work. I don't know why I put it over there. I'm so sorry. 2 and 1. Ooh, negative! See, you saw where my brain was going. What if I did negative 2? What's the absolute value of negative 2? It's positive 2. It works. Okay. What about 0? Can I do 0? Yeah. What's the absolute value of 0? It's 0. 0 is less than 3. What about 3? What about plugging in 3? Why not? Because it doesn't say or equal to. So what kind of circle am I going to put at 3? Open. What about at negative 3? Open. And then you're going to make this, and I'm hoping that your brains will see that we talked about this yesterday. What word goes with this? It's a conjunction, and what word is conjunction? And. So this is and. So anytime we have an absolute value inequality where the symbol says less than, you're going to be using the word and. So like for this one, you would write x is less than 3 and x is greater than negative 3. This is graphed right up there. This and that are the same thing. So anytime you see less than, it's going to be and. Let's do the next one. The next one says the absolute value of x is greater than 3. What values will work for this one? 4. Very good. 4. 1, 2, 3, 4. 5. You see where we're going with that one? Okay. What about on the other side? Negative. Negative 4. Negative 5, so we're going there. Excellent. Now, what about 3 and negative 3? What about 3 and negative 3? What about 3 and negative 3? Those won't work because it doesn't say or equal to. So I have to put an open circle there. And you should see that this right here, they're going the opposite ways. So it's a disjunction, so the word or. Yes, Aviana.
It doesn't have the equal sign. Why do we include it?
Am I including it?
Why do
We put the open circle, because if I don't put the open circle, remember before I put it, do you see how we stopped at 4? But 3.5 would work. 3.1 would work, but 3 doesn't, so we put an open circle. That's a great question, maybe. Now, what if this had said greater than or equal to? Then these circles would have been filled in. That's the only difference. Okay, so anytime you see the symbol greater than, you're going to put or. All right, so this one would be x is greater than 3 or x is less than negative 3. All right, so there's a catchy way. It's silly, but I'm going to show it to you because it does actually help your brain remember this. To think of it as greatOR, then greatOR, then, and less than. Less than. I know it's silly, but it works. greatOR, then less than. Okay? You good? Okay. So let's try one. What's the first thing I always have to make sure when I'm solving absolute value equalities or inequalities? Aviana? Very good. Nothing on the outside up here in front, and nothing on the outside in the back. Is there anything in the front or behind the absolute value? No. So we would call this the first checkpoint. Now, yesterday, we only used what word at the end with absolute values? Yesterday, the last half of class, we only used OR, all right? But today, it could be OR, it could be AND, right? Sorry, Frank. So, let's look at the symbol. greatOR, then. greatOR. So this is going to be OR.
Or.
Now, watch what I write on the right side. Watch what I write down on the right side. 2x plus 1 is greater than 5. Do you see how that's exactly the same? Hey, you! Do you see how that's exactly the same? You see that's exactly the same, just no more absolute value.
Yeah.
No, you don't, Frank? It's exactly the same as this with no absolute value. Correct, and we put OR, so we're allowed to take off the absolute value, right? Your brain's all over it. I love it. So now we have 2x plus 1. Now watch what happens here. Yesterday, we made the 5 into a negative 5. Remember that from yesterday? We're going to do that again. That's going to be a negative 5. But this time, the greater than sign, because it's not an equality, it's an inequality, you need to change the inequality to be the other one. Because I just proved, right here, I just proved that when you do OR, it looks like this. All right? Take a look. Alonzo. All right, see how this one looks like that one? What about on this side, though? The inequality changed and the sign changed. Because it wasn't an inequality. If it's an equal sign, we just keep it as an equal sign. Remember, see, that's just a slight difference. Okay, any questions on how to get here? This is like the second thing I care about. If I don't see these two things, I'm going to make sure we talk about it. Yes, Leslie. Which sign changed? The inequality symbol will always change on the one on the left. Anthony. No, this is like the new stuff. Everything from here on out is just doing algebra. Nothing new. Can you just throw it over against the wall? Right, you've been touching for 5 straight minutes. Great, cool. Okay, so to solve, I'm going to subtract 1 on both sides. You'll see the work is the same here. So 2x is less than negative 6, or 2x is greater than positive 4. I'm waiting for people to catch up, right? It's a teaching thing, a tool where you just kind of pause for a second, because I'm going faster than you. Now to get those 2's to go away, you're going to divide both sides by 2. So x is less than negative 3, or x is greater than 2. Yes, Aviana. Great thought. If we had been dividing by a negative here, yes, we would be flipping both inequality symbols. Yes, that didn't happen here, but that's a good thought. It could happen. Anthony. The rule is, whenever you multiply or divide by a negative, you change the inequality symbol. That's what she's clarifying. That still happens. We're still in the world of algebra. But what I'm saying is, if it's a negative 2 here, Anthony, it's also a negative 2 here. Yeah. So you'd be doing both. So both would end up flipping. Of course. But those are separate things. I don't want your brain to think that those are related. Okay. So let's draw a quick little sketch. I know there was a number line there, but I want to show you how to do it just a little faster to save you some time when you go to your spots. All right. What kind of circle is going at negative 3? Open. What about at positive 2? Okay, now what direction am I moving for less than negative 3? To the left. Let's wake up, come on. Right, one of the most challenging lessons we're going to do all year, and you're sleeping. What about this one here? Greater than 2? To the right. To the right. How can I tell? What are values that are greater than 2, 3, 4, 5, 6? Those are all to the right. Now, ask your brain, does this match up? Does OR and this graph, do those make sense? Are they linked? Do they make sense together? Yes, OR means disjunction away. If it doesn't work out that way, if you had OR but the graph looks like AND, or if you had AND and the graph looks like OR, and all of your work is good, you have what we call a contradiction. And I'll show you later that just means you need to go back earlier in the problem and something interesting is going on. Okay? Something interesting. Good interesting. I mean, I think they're great. Any questions on this one? Let's do the next one. One more all together, and then you're going to try 6 of them. Okay, number 2 says the absolute value of 2x plus 7 divided by 3 is less than or equal to 1. So that first thing I have to make sure is the absolute value by itself. It's not. Why not? It's divided by 3. You see how the 3 doesn't have, like it doesn't come all the way down? So it's not in there. So how do I get rid of dividing by 3? Multiply. Awesome. So I'm going to multiply both sides by 3. Now I get a lot of students that forget that whatever you do to one side, you got to do to the other. Right? I think I had 5 students in my last class that forgot to do this one little step. They did all of their work, so they got the wrong answer just because of one little thing they forgot to do. Okay? So we're going to multiply both sides by 3. So now we have the absolute value of 2x plus 7 is less than or equal to 3. And now I have my first checkpoint. What word am I going to use for this inequality symbol? Remember, less than. Less than. Okay, on the right side, rewrite it exactly the same, but you're allowed to take off the absolute value. So 2x plus 7 is less than or equal to 3. What's the left side going to become? Very good. You change the inequality symbol, and the number becomes the opposite as well. Always. For always and forever. Okay, so are we all good? We're ready? We see that this is kind of the main thing I'm looking for. If I don't see these 2 things today, you're going to be hearing from me. Okay? Not in a bad way, just we need to make sure you know how to do those 2 things. Everything else is just algebra, so minus 7 on both sides. So, is there a question? Then you're going to hear from me, right? What I do? It's called surface, and you have a pen and you write. For funsies. No, this is not for funsies. You got to do this. For funsies, it means it's just extra. Hashtag. Right, no cap. It's okay, you missed it. So x is greater than or equal to negative 5, and x is less than or equal to negative 2. Great question. What do you think it is? It says solve and graph. So the answer, again, but is that the only thing I'm looking for? It's actually not what I'm looking for. What am I looking for, Anthony?
The answer.
No, that's not what I'm looking for. I'm looking for the first checkpoint, and I'm looking for the conjunction or disjunction that you write. If I don't see this, I don't even care what's going on after, because you need to do this right. Once I see this, Anthony, then yes, I'm going to check for the graph, and Anthony, I'm checking for the statement here, the conjunction. You don't have to put the check mark, it's all good. I'm going to be looking for that, though. What? The other line, I don't like it because I want to show you how you can go faster and just use the numbers. Like you don't have to put 0 and all that. Okay? What kind of circles are going at negative 5 and negative 2? Closed. Anthony, come on, you're already behind. Oh, you did? Okay, cool, awesome. What are values that are greater than negative 5? Great, so that's going to the right. What about less than negative 2? To the left, so you should see that they come together. We're not going to cross over each other. And it's and. Does that match up with and? It does. Any questions on this process? Okay, so before I send you to your spots, because you have 20 minutes when you get there to do these 6 questions. Okay, I know it's a long time. But let's just take a look at the 6 questions we're about to do. Look at the first one. Just visualize what you're going to do with the first one. Visualize, not vocalize. Visualize what you're going to do with the first one. Okay? Visualize the second one. Visualize what you're going to do on the third one. Ooh, the fourth one. And the fifth one. And the last one. Everybody ready? All right, let's get started. Go!